Hi students, ഇന്ന് നമ്മൾ ചെയ്യാൻ പോണത് പാർഷ്യൽ ഡെറിവേറ്റീവ്സ് എന്നുള്ള കൺസെപ്റ്റാണ്. നിങ്ങൾ ഡിഗ്രി ലെവലിൽ പഠിച്ചിട്ടുണ്ടാവും പാർഷ്യൽ ഡെറിവേറ്റീവ്സ്. അത് തന്നെയാണ്. നൊട്ടേഷൻസ് ഒക്കെ ചിലപ്പോൾ കുറച്ച് വ്യത്യാസം പറ്റുമെന്ന് വരും. That's it. So let us begin. Let us start with an open subset E of Rn, and let f be a function defined on E to Rm. Now take standard basis E1 etc. En of Rn and U1 etc. Um, the standard basis of Rm. Okay, now f is a vector valued function. How many components f has? F is a function from E to Rm. So f has m components. So the components of f be f1 etc. fm. So I can write f of x is equal to ordered m tuple f1 of x etc. fm of x. So this is written as an m tuple. Now how do I express this m tuple in terms of the standard basis of Rm? It is as a linear combination. How do you write? Sigma I is equal to 1 to m fi of x ui. Okay, now I am fixing an x in E. Now for I varying from 1 to m and j varying from 1 to n, we are going to define the partial derivatives. So notation is dj fi of x. dj fi of x, how it is defined? So take the ith component of f. So it is fi. I am going to define the partial derivatives dj fi at the point x. At the point x. So dj fi at x, it is look at the quotient. Take the ith component of f, namely fi. Evaluate it at the point x. Then take a neighboring point of x, but only in the direction. The change happens only in the direction of ej. So fi of x plus tej minus fi of x divided by t. Look at this quotient and take limit as t tends to 0. If this limit exists, we say it is partial derivative of fi in the direction of ej and denoted by dj fi of x. Hope you understood the definition. Now if you write x is equal to x1 etc. xn, and you write x plus tej as x1 etc. xn plus t times 0 0 etc. 1 comma 0 0 etc. 0. That is your ej, where 1 occurs in the jth position. So what will be x plus tej? It will be precisely this vector x1 etc. xj minus 1, then xj plus t comma xj plus 1 comma etc. xn. using the definition of addition in scalar multiplication. In Rn, you have x plus Tej is this vector. Now substitute in this equation. What I will get? I can see that it is limit t tends to 0. Fi of, substitute for x plus Tej with this, minus Fi of x divided by t. So we will get dj Fi is the derivative of Fi, because I am looking at Fi here. Derivative of Fi with respect to xj, because the change happens only in the direction of xj, keeping the other variables fixed, because all the other variables x1, etc., xj minus 1, xj plus 1, etc., xn, all these are fixed. The change happens only in the direction of xj. So you observe that when you write x as an n tuple and x plus Tj as an n tuple, we can get that dj Fi is the derivative of Fi with respect to xj, keeping the other variables fixed. dj Fi, that is also denoted by dou Fi by dou xj, and it is called a partial derivative. Now I would like to ask you a question. How many partial derivatives are there for this particular f? Think over it. You can get from this slide itself. We will move to the next slide. We will prove a theorem. Suppose E is an open subset of Rn, f maps E into Rm, and f is differentiable at a point x in E. Then the partial derivatives of f, all the partial derivatives exist, and f dash x into Ej is equal to sigma I equal to 1 to m dj Fi of x times Ui. So understand, Ui are vectors, dj Fi of x, these are actually scalars. So this is scalar multiplication. Therefore this sum in the right side, that is a linear combination. First, let us make a remark of this theorem. You know f dash x is a linear transformation. From where? From Rn to Rm. We have learned it. Derivative is a linear transformation. Every linear transformation has a basis representation with respect to the given basis. Here the given bases are, remember, standard basis of Rn and Rm respectively. So let f dash x matrix be the matrix that represents the linear transformation f dash x. Okay, now given an m by n matrix, matrix Aij, call it capital A. What is Aej? Ej is the jth basis vector. So Aej, remember, it represents the jth column of A. It represents the jth column of A. Therefore, f dash x into Ej, f dash x is a linear transformation. So it represents the jth column vector of the matrix, this thing. So we can write down the matrix for the linear transformation f dash x. How it will look like? So what is the jth column? F dash x Ej. What But f dash x ej is precisely given by this one. Sigma I equal to 1 to m dj fi of x times ui. So what is the jth column? It is dj f1 at x. Next is dj f2 at x, etc. Last is dj fm at x. That is the jth column. Hope you understood. And therefore you can write down the matrix of f dash x with respect to the standard basis of Rn and Rm in this way. What is the jth column? It is dj f1 at x, dj f2 at x, etc. dj fm at x. In particular, this is the first column, etc. This is the nth column. Now we shall prove this theorem. So first fix a j in the set 1 to etc. to n. Now f is given to be differentiable at x. So since f is differentiable at x, remember the definition of differentiation for functions of several variables. You can have such an expression: f of x plus h minus f of x is f dash x times h plus r of h, where limit h tends to 0, norm of r of h divided by norm of h is equal to 0. This is the definition of differentiation. This is true for every h small enough. So I am taking here h as the vector h as tej. So how do I write this? F of x plus tej minus f of x is equal to the linear transformation f dash x applied to the increment here tej plus r of tej. Instead of h, I have to use tej, where the remainder r of tej has the property limit h tends to 0. Here it is tej tends to 0. Norm of r of tej divided by norm of tej is equal to 0. Remember, the numerator norm is in Rm and the denominator norm is in Rn. Now look at the denominator. Norm of tej is precisely mod t times norm of ej. But since ej is the standard basis vector, norm of ej is equal to 1. So in the denominator we have mod t only. But something tends to 0 if and only if the norm tends to 0. Use that property. So equivalently you will get limit, instead of tej tends to 0, I have limit t tends to 0. Because if you take norm of tej, it becomes mod t. And mod t tends to 0 if and only if t tends to 0. Limit t tends to 0, norm of r of tej divided by, in the denominator you have mod t, but mod t tends to 0 if and only if mod t tends to 0 if and only if t tends to 0. So you can divide by simply t. Now look at this term, f dash x applied to the vector tej. But f dash x is linear. Therefore from this 2, equation 2, what we will get? F dash x times tej becomes t times f dash x applied to the vector ej. Now divide by that t throughout in 2. So what I will get? f of x plus tej minus f of x divided by t equal to f dash x applied to the vector ej plus r of tej divided by t. Now take limit as t tends to 0 both sides. That r of tej divided by t, its limit equal to 0 by this. And something tends to 0 if and only if its norm tends to 0. So I get limit of this equal to f dash x times ej, because I divided by this t. Hope you understood. So this is what I get. Now write this f, this is a vector function. Write this f in terms of the components f1 etc. fm. That means write f as a linear combination of the components, as in the previous slide. And remember, here you have addition, subtraction. Here it is subtraction, not addition. And again you are multiplying by 1 by t. The whole thing divided by t means multiplying by 1 by t. So it is actually scalar multiplication. And how addition and scalar multiplication are carried out? It is again component wise. So on each component of f you have to perform addition and scalar multiplication. So what do I get? If I look at the components of f, then this expression can be written like this. Limit t tends to 0, that is there, that was there. Then sigma I equal to 1 to m. So instead of f, I am using the components of f, namely fi. So sigma I is equal to 1 to m fi of x plus tej minus fi of x divided by t times ui. That's what I am going to get. Equal to f dash x applied to the vector ej. That is the right side itself. No change in the right side. Hope you understood this step. Now, when a vector function has a limit, if and only if each component has a limit. A vector function has a limit if and only if each component has a limit. So here, this is a vector function, the left side as well as the right side, that has a limit if and only if each quotient has a limit as t tends to 0. And that limit can be taken inside this sum. So what is f dash x ej? It is, you interchange this sigma and limit. So sigma I is equal to 1 to m, limit t tends to 0, fi of x plus tej minus fi of x divided by t times vector ui. But what is this thing? Its limit. It is precisely our dj fi at the point x. So you get f dash x into ej equal to sigma equal to 1 to m dj fi of x times ui. This is what we wanted to prove. Thank you.